Let's take a look at some compositions involving the inverse cosine along with cosine. So remember that we can start on the inside and work our way out. And so for this first one here, we can evaluate cosine of 7 pi over 6 first. So let's go ahead and do that. So when we look at the angle 7 pi over 6, that's over here. And the cosine of that angle is the first coordinate. So that's negative root 3 over 2. So this simplifies to inverse cosine of negative root 3 over 2. Now let's evaluate that. So we want to evaluate the inverse cosine of a number. Inverse cosine is an angle on the top half of the unit circle. It's an angle between 0 and pi radians. And what that tells us then is that we want the angle on the top half of the circle with a cosine value of negative root 3 over 2. That puts us right over here. So that angle is 5 pi over 6. It's very tempting to want to just cancel out these two because they're inverses of each other, but we cannot do that. We have to remember that inverse cosine is an angle on the top half of the circle. So if this angle right in here is not on the top half of the circle, there's no way those will just undo each other. So we work our way from the inside out. Cosine of 7 pi over 6, negative root 3 over 2. Inverse cosine of negative root 3 over 2, 5 pi over 6. Let's try another one. Inverse cosine, angle on top. And here, cosine of 2 pi over 3. What we notice is that this is an angle on top. 2 pi over 3 is an angle on the top half of the unit circle. It's right there. So our hunch is that in this particular case, we probably can just cancel those two functions out. Well, let's try. Let's start on the inside. So that's going to be inverse cosine of cosine 2 pi over 3. We go to 2 pi over 3, which is right here. And cosine of 2 pi over 3 is negative 1/2. And then inverse cosine of negative 1/2 is the angle on the top half of the unit circle with a cosine value of negative 1/2. And that, in fact, is 2 pi over 3. So the moral of the story, if this angle is in the range of that inverse trig function, then there will be the cancellation property. Let's reverse the order here so that the inverse trig function's on the inside, the regular trig function's on the outside. What we will see in this case is that we can always just cancel. But let's just play it safe. So this is going to equal the cosine of inverse cosine negative root 3 over 2. That's an angle on the top half of the unit circle with a cosine value of negative root 3 over 2. So that angle is 5 pi over 6. And then cosine of 5 pi over 6 is the first coordinate, negative root 3 over 2. So, oh yeah, those would have canceled and that would have worked. Another one. Again, let's do it step by step. Inverse cosine of 1/2. That's the angle on top with a cosine value of 1/2. That's pi over 3. Cosine of pi over 3 is 1/2. So, if the regular trig function's on the outside and its inverse is on the inside, the cancellation property will apply. If the inverse trig function's on the outside and the regular trig function's on the inside, the cancellation property only applies if the innermost angle is in the range of the outermost function. Hope that helps.